So we have already studied about reaction of metals with water and oxygen. Now I'll be studying the third category of reaction, that is reaction of metals with acids. Metals react with acid and they produce hydrogen gas with the formation of salt. Means what happens here is metal replaces hydrogen from its acid. Okay, so you can say that metal above hydrogen in reactivity series displaces hydrogen in acid and forms salt with liberation of hydrogen gas. Okay, now when we talk metals above hydrogen in reactivity series, it means those metals which are having their position above hydrogen, they are more reactive than hydrogen, and that is why they will displace hydrogen from its salt acid. So this is also again an example of, we can say that it displacement reaction. Okay, so suppose Zn, which is in the form of solid, and we are taking here dilute H2SO4, then there will be formation of salt, that is zinc sulfate plus H2 gas. Now the name of this salt form is zinc sulfate. So the product are zinc sulfate and hydrogen gas. Similarly, we can see for other metals such as aluminium, which reacts with an acid such as HCl, that is hydrochloric acid, okay, and it will form salt, that is aluminium chloride AlCl3 plus H2 gas, that is hydrogen gas is liberated again here. So in this case you can see the salt form. So in this case you can see the salt form is aluminium chloride. So we can say that the salt of the acid is formed and hydrogen gas is liberated. In the case of H2SO4 and HCl, hydrogen gas is liberated by the metal above it in the reactivity series. But when I talk about HNO3, we will see that metals, they react with HNO3, okay, that is nitric acid, but not only they do not liberate hydrogen gas only, they liberate their another gas, that is nitrogen dioxide gas. That is why we do not study here the reaction of metals with HNO3. Okay, for example, if I say that zinc reacts with HNO3, that is nitric acid, then the formation of salt should be there, that is zinc nitrate, and hydrogen gas should be liberated. But as HNO3, that is nitric acid, is an oxidizing agent, means it will oxidize and it will form salt plus NO2 gas also. Okay, so that is why we do not consider these reaction over here, because they do not just liberate H2 gas, they liberate NO2 gas, that is nitrogen dioxide gas. Okay, only the metals which react with HNO3, that is the metals such as magnesium, the metals such as manganese and magnesium. These two react with HNO3, they form their metal salts and liberate hydrogen gas. Okay, so we can say that these react with nitric acid and form salt, and so only these two metals react with nitric acid and form salt and hydrogen gas. Other all metals which react with nitric acid, they form the metal salt and With that they will liberate the nitrogen dioxide gas. Okay, so we can see that this is the basic difference here of the acid, that is nitric acid, as compared to other acid. We can take few more examples of metal reacting with acid, that is Na, sodium. It reacts with H2SO4 and it will form the salt, that is sodium sulfate, NaSO4, and liberate hydrogen gas. Okay. Similarly, potassium will also react with acid, that is sulfuric acid, and it will form its salt. So basically we can see over here that the metals are reacting with acid and they are liberating hydrogen gas. If I want to take an example of reaction with another metal, that is like copper. Okay, if I react copper with any acid such as HCl, then there will be no reaction. Why? Because copper is placed below hydrogen in reactivity series, and hence it will not be able to displace it. Similarly, you can say metals such as copper, silver, gold, platinum, mercury, etc. do not displace hydrogen from acid. Okay, hence we can say that copper will not react with acid to produce its salt and liberate hydrogen gas. Okay, so this was the reaction of metals with acids. Okay. Now here we can see that the metals, they are reacting with acids and they are carrying the displacement reaction. Okay, so all the metals, they will react with acids? No, as I have said, only those metals which are more reactive than hydrogen and are placed above hydrogen in reactivity series will react, and the less reactive metal, they will not react with. Now we'll see the reaction with base. Reaction of metals with base. Generally, strong alkali, they react with metals and they form salt and liberate hydrogen gas. So we can say that few metals react with base. Okay, here we can take example of beryllium. Beryllium, it reacts with a strong alkali, that is NaOH. Okay, and it will form a salt, that is sodium berylate. And liberate hydrogen gas. Okay, the arrow I am showing, it means it is in the form of gas, it is being evolved. Here salt is formed, that is sodium berylate. Okay, so we can say that some metals, they react with alkali and they will form the salt and liberate hydrogen gas. Okay, more example we can take of metal, that is zinc. Zinc will also react with alkali, that is sodium hydroxide, and it will form sodium zincate, that is Na2ZnO2, and liberate H2 gas. Okay, here the name for the salt will be sodium zincate. Even aluminium reacts with alkali, that is aluminium reacts with sodium hydroxide and it will form sodium aluminate. Here the salt that is formed is sodium aluminate. Okay, now we can see that some metals, they are reacting with alkali and they are forming their aluminates. You can see most of the metals that they are the metalloids, that is the acting as. Here you can see that those metals which form amphoteric oxides, generally they are reacting with the alkali. Even tin and lead, they also react with alkali and form the salt. Okay, so we can say that few metals, they react with alkali and they form the salt and liberate hydrogen gas. So this was the reaction of metals with base. Here the sodium aluminate which is formed is white in color, and it gives a very cloudy appearance. Means you can say that gelatinous appearance is seen when this reaction is carried out. So salt which is formed is gelatinous, gelatinous appearance salt, and it is white in color. Okay, so this was the reaction of metals with bases. Metals also react with hydrogen and nitrogen. So the next we are going to take is reaction of metals. The alkali and alkaline earth metals, they react with hydrogen and they form their hydrides, as those metals are more electropositive. Okay, they are more electropositive than hydrogen, and that is why they will donate its electron to hydrogen, okay, and form its hydride. So you can say that, we can say that alkali and alkaline earth metals react with hydrogen and form metal hydrides. The metal, can say, these metals are more electropositive, that is, lose electron more readily than hydrogen. Okay, so what will happen, that the alkali and alkaline earth metal, they will form ionic compounds, like the hydrides will be ionic. Okay, so the hydrides, they will be ionic in nature. The reaction, what is, we'll see an example what is happening over here, and then we'll understand it more clearly. For example, I take here, the first shell, innermost shell, is having 2 electrons. We can see this is a sodium atom. Okay, now what happens is, this sodium atom, it loses 1 electron. Okay, and what is formed is sodium ion. Sodium is more electropositive, it loses electron easily than hydrogen. Okay, and this electron is then accepted by hydrogen. Hydrogen, which is having only 1 electron in its shell, okay, it will accept this electron, this electron is accepted, by hydrogen, and what it will form, you can say, I have added that electron over here, and here now it will form a hydride ion. It has completed its duplet and has become stable. This is the electron which it has accepted from sodium. Here it is, hydrogen is accepting electron, and hence it is forming H minus. This ion is called as hydride ion. Okay. So now there will be electrostatic force of attraction between the two ions, and now they will form sodium hydride. Okay, that is, okay. So we can say here what is formed, is one atom of sodium Na plus ion is combining with one atom of H minus, and here it is forming a compound, ionic compound, that is sodium hydride. Similarly, we can say that calcium, magnesium, these also react with hydrogen to form their respective hydrides. So we can say over here that the alkali and alkaline earth metals, they react with hydrogen and form their hydrides. Similarly, other alkali and alkaline earth metals react with hydrogen and form hydrides. Now we'll see the reaction of metals with nitrogen. Here also, the more reactive metals, that is the alkali and alkaline earth metals, they will react with nitrogen and they will form their respective nitrides. Here we can take an example of sodium. Sodium on reaction with nitrogen, it will form sodium nitride. This is also an ionic compound. Here sodium is losing its one electron and that electron is being accepted by nitrogen. Okay. So here sodium reacts with nitrogen to form sodium nitride. Again we will draw a representation that will be easy for us to understand. Here I take again the example of sodium atom. Now this sodium atom, it forms sodium ion by losing its one electron. Nitrogen, which is having 5 valence electron, requires 3 electrons to complete its octet. Now it is having 3 electrons to complete its octet. It requires 3 electrons to complete its octet. What it will do? It will accept electrons from sodium. Now sodium, one atom of sodium will give it one electron. So for one nitrogen atom, I require at least 3 sodium atoms. Okay, so we can say that to complete the octet of nitrogen, I am requiring 3 electrons. These electrons are provided by the sodium atoms. So for one nitrogen, I require 3 sodium atoms. Okay, plus 3 electrons, it will form now the ion formed here is nitride ion. Now again there is a force of attraction, electrostatic force of attraction between this, and that is why they will form an ionic compound, that is sodium nitride. Hence we can say that, so one formula unit of sodium nitride, it contains 3 sodium atoms and 1 nitrogen atom. Similarly, other ionic compounds of nitrides are also found, such as calcium nitride, magnesium nitride. Okay. Similarly, other alkali and alkaline metals For example, magnesium will form magnesium nitride, that is Mg3N2. Calcium will form Ca3N2. So now we have completed the reaction of metals with all the, similarly we have completed the reaction of metals.